It's late at night. I should be in bed, but I'm not going to because I'm super excited to show you about properties of a quadrilateral. I need to be quiet so I don't wake other people up, but it's not going to hold my excitement. Let's see. What if the diagonals are bisected? Is that enough to show that this quadrilateral is a p-gram? Given that the diagonals are bisected. Now BEC is congruent to DEA. BEC, badum. DEA, badum. Vertical angles. Wow, a triangle congruent statement already. That's because of SAS. And always after a congruent triangle statement is going to be some parts of that congruent triangle are going to be congruent. The corresponding CPC, TC, which ones are they? Angle EBC and EDA. EBC and EDA. I'll make 2 marks there. Oh, now because when 2 lines are cut by a transversal and alternate interior angles are congruent, those lines are parallel because of the converse of the alternate interior angles theorem. I'm going to clean this up a bit and know that we're halfway done because we have these sets of lines parallel. What happens next? BEA and DEC are congruent. BEA and DEC. Okay, I'm going to make these a squiggly mark here and DEC angle mark because those are vertical angles. And then we have another triangle congruent statement, very similarly, because of SAS. It's just these triangles here. And that's because of SAS. Similarly, angles of those triangles, corresponding parts of those triangles, are congruent. And that's EBA. EBA. Running out of ways to characterize this. There we go. And EDC. Well. When 2 lines are cut by a transversal and alternate interior angles are congruent, those lines are parallel. We now have a quadrilateral with 2 sets of parallel lines. Opposite sides are parallel. We have a parallelogram. Oh my, there's more. Oop, I got my notes here. Gotta need to take that off. Doo-doo. This one is, if one pair of opposite sides of a quadrilateral are parallel and congruent, so they got a lot going on with them. One side are parallel and congruent, what do we have? Step 1, given. And the marks are in there. Step 2, CBD, ADB, CBD. Because when parallel lines are cut by a transversal, look for the Z. Alternate interior angles are congruent. There's the Z. It's backward, but it's there. That means this one and that one. Oh, also CAD. Parallel lines are cut by this transversal now. You see it? Now it's this Z. Alternate interior angles are congruent. That would be that set and that set. Alternate interior angles. Got a triangle congruent statement. CBE is congruent to ADE. That's for angle, side, angle. We didn't even need those vertical angles in there. That's good. And now because they're congruent triangles, we've got corresponding parts of congruent triangles are congruent. That gimme is BE is congruent to DE. I'll make 1 mark there and 1 mark there. And CE is congruent to AE because those are corresponding parts. Choo, 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 choo. Looks like we have BD and AD bisect each other because the definition of a segment bisector. Wow, what were we trying to prove? That ABCD is a parallelogram? We've got, oh no, sorry, that AB is parallel to CD. Did I miss something? Let's see. ABCD is a parallelogram. We need both sets of sides parallel. When two lines are cut by a transversal and alternate interior angles are congruent. Let's see, did I miss something? Man, I'm thinking that when two lines are cut by a transversal and alternate interior angles are congruent, those are congruent there because of, well, we need to prove that those triangles are congruent. Man, did I miss something? Not quite sure. But I'm going to stop it right there because it's late. And I think if it's just last one, it's the definition of a parallelogram. Leave comments if